right? So again, these are the summaries. This is the summary of all of them. So reflection in the y-axis, reflection in the x-axis, and then so reflection in the y-axis is when you reflect across the y-axis from left to right or from right to left, and then reflection in the x-axis is when you take things above and put them below, or below and put them above, and then vertical translation is when you take everything and you move it to the left or to the right, and then sorry, up or down, vertical, up or down. The horizontal translation is when you take everything and you move it left or right. And again, these are the pages. I neglected to copy this page for you in your notes. That was my mistake. But they are individually on these pages. Page 27 is where this one is. Page 30 is where this one is. Page 35 is where this one is. And page 41 is where this one is. And I would go through those pages and dog-ear them and highlight them. So again, we'll start with page 41 since I already did all the other pages earlier before I started recording. See, this is page 40 right here, you can see. Here's 41. So this is the beginning. It loops between 41 and 42. So here's the beginning of it, right? If you want to go y equals f of x, you want to move it right h units, then you replace x with x plus h down here in the bottom. It's this part down here. Right, it's this stuff. Oops. Uh-oh. Draw. So you can see it. It's the combination of that with this, and the other ones here as well. If you want to go left by h units, sorry, this is right by h units, then you would go, you'd replace x with x plus h. And then I'll show you the ones for page 35 again. .35 is right here, right? Vertical translation. Again, if you want to shift something up k units, you would just add k, that amount to the end. If you move it down, the whole function down, you just subtract that amount from the end. So the up and down, that's on the outside of the function. You just tack it on to the end. I call it on the outside of the function because the function's really right here where f of x is. And you just throw it onto the end. You tack it onto the end. To translate, if you translate left or right, that's on the inside of the function, right where x is. Right inside where x is, you change x. You put parentheses instead, and instead you do x minus to go right. It's the opposite, remember, because it's on the inside. And you do x plus to go left. And again, it's the opposite because it's on the inside. You think you'd go minus to go left, but instead you go plus because it's on the inside. So these are these guys here. And again, I would highlight those on your pages in your notes. And then these other two are on pages 27 and 31, like we saw as well. So I'll show them to you again briefly, even though I should do them again earlier. 25, 26, 27. It's right there. What do you do in this role? So oh, sorry. Can't get to go to jive right, but it's right. Oops. There, it's right there. This is the rule. And then page 27, it's not that far away. 24, oops, that was page 27. Sorry, page 27 is that rule. And then page 30 is the other one. Right there, page 30. So those are the 4 rules that are summarized on this sheet here. So you could just take a picture of this if you want as well and have it. But, you know, I feel like you've got them all in your handouts, so you should be okay. So again, just to summarize, if you're reflecting, in other words, if I want to reflect across the y-axis, so this is, here's my axis, and I want this to go, well, it's not quite right, but it's about right, to go there, across the y-axis. Then I replace all the y's stay the same, the x's become negative x, opposite. If it's negative, it becomes positive, if it's positive, it becomes negative. So I just replace the x with negative x. If I reflect across the x-axis, right, that's where my smiley face here would go there. Then the x's stay the same, the y's become negative y's. So remember, f of x is y. So I'm going to replace f of x with negative f of x. In other words, I'm going to multiply the whole function by -1. I'll type that in there. Multiply and then if I want to translate, then I just, if I want to go up and down, I just tack it onto the end of the function on the outside of the function. And if I want to move it left or right, then I replace x inside the function with kind of the opposite. If I want to go left, I would add the amount I want to shift, and if I want to go right, I would subtract the amount that I want to shift. Okay, so that's the basic summary of all of this. And we're going to go ahead and move on. First of all, how are you all doing? Everybody hanging in there, doing well?
The sky is orange.
I know, it's so bizarre. I drove into campus today, and it was just, it felt like one of those like Tom Cruise movies where like the world is coming to the end or something like that, you know, because it's just, it's very surreal and kind of spooky a little bit. Yeah. It's very disturbing.
I at first when I looked outside, I was like, oh, it reminds me of Pirates in the Caribbean.
Oh yeah.
Am I in the ride or what?
Exactly. It totally does remind me of, you're right. It's totally Pirates of the Caribbean.
It kind of reminds me of back home in Mexico. I don't know
really? The air quality is this bad there?
Burning out there, so it always smells like smoke. It's one of my favorite things about that place.
Wait, they're always doing what there?
They're always burning crops because crash and burn something. I forgot. It's a way of farming, I guess. Farming out there. So they'll use that technique a lot. And it's just like, it doesn't really do anything but make the land, you know, burn.
Okay. And you miss it?
Kind of. I miss the smell, I guess.
You get used to it? Good deal. Nice.
Yeah.
Yeah, I mean, maybe their crops, they smell good when they burn.
Maybe. Right. That might be why.
Yeah, they might. Good deal. So, and are there any, so this is how we're doing today. I'm going to see if you guys have any homework questions. I just did the function transformation summary. And then we're going to work on composition graphically, which again is jumping back to pages 15 through 20 in our handout, our Unit 2 handout. It's Jamboards 1 through 4. And after that, we'll get to intro to inverses, which is at the end of the packet, the very end of the packet. I think the last like 8 pages of the packet. And then that'll be it for today. I don't know that we'll get through all of that today, but we'll try. And then today you have some written homework. The working with functions is due tonight at midnight. You do not have a Connect Math, sorry, my Math Lab homework due tonight. You do need to, at this point, have bought my Math Lab if you didn't have it before, because your trial has expired at this point. So, you know, you need to, you know, kind of commit. Your deadline to drop was yesterday, so none of you guys dropped. So you'll need to do that because your next My Math homework coming up is not till next Monday. We've had to shift some things they got kind of clumped weirdly. So, you know, we have some written homeworks coming up, but really nothing in my math lab for a little bit because we deleted a couple ones that we thought weren't as useful. So you have your other vertical translation homework due on Friday. And then next Monday, you have your my math lab due, the one we're covering today. And then next Wednesday, you'll have linear equation review, which we'll cover on Friday. But it's also just kind of some just review of linear equation information that you guys probably know already. Okay, so, but you maybe forgot that you knew it. If that makes any sense. So let's go ahead and see if there's, first of all, are there any homework questions you guys have about any of this stuff coming up?
What are the pages?
What was that?
What are the pages for today?
Great question. So the pages for the homeworks, I mean for the, that we're doing today?
Yes.
I don't know yet because we haven't finished. So that's a great question. And until we finish today, I won't know. So you have to do them all. Everything we're doing today, you have to do. And at the end of the day, I will tell you which ones I decide to use.
Okay.
Yeah. So, but the written homework working with functions, that, if you're wondering what that one is earlier.
And are you going to post that up on Canvas after class?
Yes.
Okay.
So the, yep. I don't know if it was this one. I don't think this was a homework. So the working with functions homework is, here it is. So this is page 11, 12, 13, 14. 11, 12, 13, 14.
Is it on Canvas right now?
This one? Oh, did I not put it up there yet? I might not have.
I don't think so.
Okay, that's a great question. I'll put it up when you guys go into groups and get that up there. And then the vertical translation one is more towards the bottom. It's after reflections. There it is. So this one is pages 33. Well, you don't really need to turn 33 because there's nothing you did in 33. So I need pages 34, 35, 36, 37, 30, yeah, so 34 to 37. Those are the pages I need for that one.
Which one's that for, Mrs. Young?
That's the vertical translation that's due on Friday. So
Oh,
pages
okay.
34 through 37 you need to turn in on Friday. Pages 11 through 14 you need to turn in today. Under written homework. Don't turn it in under our attendance. That's not our attendance for today. This is the written homework that's due. So that'll be under assignments under written homework. So if you go to Math 50, assignments, where it says assignments, then how is this? Oh, that's math department. No wonder. It's the wrong course. It's not your course. Math 50, under assignments. You'll see your proof of attendance, which I have not chosen for today yet. And then you'll see the written homework. Oh, sorry. I should probably move this one up to the top. It'll be at the top or the bottom, you know, the ones for today. I don't know where I'll put it. It'll be, but it's under the date. And then written homework. This one here, the working with functions, is due. Working with functions. I'll put 11 through 14. So that's due today at midnight. 10 points. All right, so I'll finish up the information on that one after I send you guys off. In the meantime, what I want to work on is, so no homework questions. Let's go and take a look at composition graphically. But I'll show you guys this one. So you're going to be turning this page in. You probably want some information about, you need to do it online, uploading a PDF, and save it as one PDF file. I will bounce it back to you if you don't. You can turn it in later on if you want. But let's see if I can find the notes. So you need to scan those pages. Let me get to it. Scan pages 1 through 14 in Unit 2 as one PDF file. So this one is the working with functions. Working with functions. Homework, which is pages 11 through 14 of your Unit 2 notes. And save them into one PDF file. If you're not sure how to do that, look at this link. If I click on this link, I'll open it up and then upload those files here. So it opens up a link right here, which will show you how to save them as one PDF file. So you'll have to take a picture, and then I think it's like right around the 58 second mark for the Android, and right around the 35-second mark for the iPhone. It shows you how to scan multiple pages. So you take another picture for the next page, take another picture for the next page, and then you'll save them all as one PDF file. But again, the link is this is the video for iPhone. You can do it either through your Notes app or through Cam Scanner, either one. And then for an Android, you do the top one. Here's the Android one. It's just Cam Scanner. It's a free app. They're all free apps, so they're really good. Like I said, if you have an iPhone, you can either use Notes or Cam Scanner, either one. And I think for Android, it's around the 58-second mark where it shows you how to do multiple pages. And I think for iPhone, I think it's around the 35-second mark. Okay, good. So let's go ahead and hop into the next thing. Are there any other homework questions before we hop in? Okay, so today we're going to be working on composition graphically. So we're in Unit 2 still. Next class we'll start in on Unit 3, but right now it's just Unit 2 still. So composition graphically, which is pages 15 through 20, hop in there. I will do the same. Pages 15, so we're going backwards. It's more towards the beginning. And here it is. So composition graphically, it's not hard, but it's a little bit weird. So you just have to pay attention and you're going to be fine. It's not challenge. It's not difficult. It's just kind of you just got to pay attention. It'll be fine. You guys are going to be fine. So let's get someone to go ahead and read the first part of this. How about Michael? Can you read for us?
Yeah, what part again? Sorry.
Just the introduction is fine.
The word composition is often used in, hold on, I gotta expand that.
Or just go to your own page, page 15.
Oh, okay.
That'd be easier, right, than reading it off the board?
Yeah, just my room's kind of dark.
Okay. I'll have you read a little bit later on the page. I'll have Giselle let you read for now, and then Michael, you can take the second part.
Okay.
So Giselle, are you? on the right page?
Yeah, you said the next part.
The introduction, yeah.
Okay. The word composition is often used in the arts and literature. For example, a musical work is called a composition. A composition book is a bound notebook of one paper intended for writing exercises. Art critics talk about the composition of a painting. In general, a composition may be thought of as putting together parts into a harmonious whole, of creating something new out of existing forms. Do you want me to read that last paragraph too?
The last part, yeah.
So what do mathematicians mean when they talk about composition? Well, it's not unlike what musicians, writers, and artists mean. In mathematics, composition refers to the creation of new functions by combining existing functions in a special way.
Right. So composition is when we take existing functions and we put them together to kind of create kind of like a machine of a sense, right? Something more useful for us. So the definition of function says, thank you, by the way, it says if for every value of the first quantity, in other words, for every value of your input, there's exactly one value of the output. So in other words, remember, just reminding you about functions in general. A function, if I put something into a function, I know what I'm going to get at. I'm only going to get one possible answer. I'm not going to get two possible answers. I'm only going to get one possible answer. Right? I throw in an X, there's only one possible Y I can get. I know for sure what I'm going to get. I don't know what it is, but I know that there's only one of them. All right, so then Michael, go ahead and start in on this recall. And again, here's a drawing, right? Function, if you have one input has only one output, then you're fine. If an input can have two possible outputs, then we're in trouble. So Michael, go ahead and read from recall.
All right. Recall that in the language of functions, we say that the output depends on the input. The result of the output occurs as a function of the input. That is the rule for the function produces a specific output based on what input was.
Great, keep going.
The composition of functions is the way of combining the actions of two or more functions into one function. It accomplishes this by using the output of one function as the input of another function. Before we get to the how of the composition, let's look at the why. Composition may seem like a rather unnecessary thing to do. However, there are real world applications of functions that rely on the notion of composition.
Perfect, thank you so much. Right, so for example, when you dine in a restaurant, the cost of the food and beverages is totaled, right? They total up your bill, and then they compute the sales tax on that total. That's a composition. Here's the process. First, input the cost of each individual food or beverage item you buy, and then you throw those into you throw that into a function. It adds them up and puts out an output, the total. Then they take that output and they throw it into another function where they compute the sales tax and add that, and then the output of that is the final bill. So that's an example of a very simple function that is used, a composition of functions that's used kind of every day, right? That you guys have experienced before. It's when something's done to an input or inputs, and then you take that output and you do something else to it, and then you get a final output, right? Like processing plants, right? They usually have multiple processes. You do something, and then you move on to something else, and then you do more to it, and you do something else. Like like making wine, you squeeze out all the grapes, and you take that output, and then you take it somewhere else, and then you mix some other things in it, and then you take that output and you stick in, store it into containers and age it. And so kind of there's a whole sort of process. How about Bo? Bo B, can you read from here? There are two stages. I kind of talked about that, so we can skip that. So that's so what they're saying is you can combine these functions into one process where you input the individual food and beverages, you add them up, compute the sales tax, and add that to the food total, and then that's your output. So putting them to one kind of larger function is what we call the composition. So that can be done graphically, numerical, and symbolically. That result is called the composite function. So we're going to look at that in this collaborative. So Bo, why don't you read this part down here from composition diagrams.
So composition diagrams, the diagrams below show the action of the two functions named f and g. Use the diagrams to write sets of ordered pairs that make up functions f and g. Great.
So let's so we'll do that in a minute. Go ahead. Oh, we'll go ahead and do that. So let's see. So the first one, G, 1 goes where?
Two.
To 2. Yeah, 1 goes to 2. So actually, let me go. Yeah, that's okay. 1 goes to 2. So I'm going to put that into my little annotation. You guys should too. So my input is 1. My output is 2. What's another one?
You have an input of 2 and an output of 2.
Someone see that one? So here's the input of 1 with the output of 2. I'll draw it for you guys in case you guys aren't sure. So the input of 1 has an output of 2. That's that first one up here. Then we have another one where the input of 2 also has an output of 2. Right, so that would be 2, 2. I can see my text. 2, 2. And then the last one on G is what?
1 and 3
to 1.
Yeah. So is it 1 to 3 or 3 to 1? Which one is it, guys? Well, I'm on G.
3 to 1.
Yeah. So look where it starts on the left and where it ends on the right. So 3 goes to 1. Good. Okay, so is everyone understanding this?
Yeah, do you just tell by that little arrow?
Yeah.
Yes.
So the arrow, the pointy part goes this way. Also, it should go left to right. But the pointy part, yeah, this is the beginning, and the pointy part is over here. So it goes 3 goes to 1.
Awesome.
All right, perfect. So everybody do F quickly and put F in here. I'll give you guys 30 seconds to write an F. And type them in the chat when you're done. So write down what they are. 30 seconds. Write down what you get for F. What the 3 points are. Write them in on your sheet. Page 16. And now everybody private chat them to me. Private chat them to me. So I've heard from 4 people, 5, 6, 7, 8, 9. 9 people only. Well, 9 people, only 9 people know what these are. 10, 11, 12, 13, 14, 15. Only 15, 16 of you? 17, 18. Yep. So tell me what all these points are. Great. So it looks like you guys have them. So you have, in parentheses, 1 goes to 3, 1 comma 3, right? Because the input and the output. And then the other point is 2 goes to 1, 2 goes to 1. And the last one is 3, looks like 3 goes to 2. Good. All right, so Bo, keep reading.
To find the composition of f and g, we use the output of function g as the input of function f. For example, from the diagram, we see that 1 maps to 2 under function g. Using the output 2 as the input of function f, we see that 2 maps to 1 under function f. Thus, 1, the input of g, maps to 1, the output of f, when composition is performed. The resulting composite function is shown at far right.
Right. So I kind of like to think of this as connecting airports, right? Here I am in I don't know, San Francisco, and I fly to Paris, and then from Paris it looks like I fly back to San Francisco. It's kind of a boring trip, but you know, it's sort of the, you know, I kind of like to think of it like that way. So you can think of this as like SF, right? Maybe Paris, and somewhere else interesting. What's another interesting place to go to? Anyone?
London.
Where was it?
London.
Perfect, London. Terrific. So I fly from San Francisco to Paris, and then from Paris to San Francisco. So really, I'm going at the end of the day, I'm going from San Francisco to San Francisco. Does that kind of make sense? I don't know. Maybe I was dropping off something highly important and classified. I have no idea. Whereas the person in Paris, they took off from Paris, they circled around Paris, and they landed back in Paris. And then from there, they went to San Francisco. So this person went from Paris to Paris, and then to San Francisco. So they went basically, end of the day, they went from Paris to San Francisco. This guy went from London to San Francisco, and then San Francisco back to London. So again, he kind of made a round trip from London and then back to London itself. Does that sort of make sense for folks? Came from London to San Francisco, and then the second function took him from San Francisco back to London. That's my kind of the way of looking at it. I'm getting no feedback from you guys, so I assume that that's okay. All right, so I'm going to go and clear this in 5, 4, 3, 2, 1. And we'll go ahead and take a look at the next page. So we have to have a, this is a composite function. One, San Francisco went back to San Francisco 1-to-1. Paris went to San Francisco, so 2-to-1. And London went back to, end up going, back to London. So 3-to-3. So to rename this new function, we have what we call f of g. So that little circle there, it's not a dot. It's not f times g. It's a circle, a very, very small circle, f of g. That's where the composition of f and g. So f of g is 1 goes to 1. Here, I'll show you. Right? 1 goes to 1, because it went from 1 to 2 and back to 1. 2 goes to 1, because 2 goes to 2 and then up to 1, so 2-to-1. And 3 goes to 3. 3-to-3. So this is the composition. Here's G, here's F. If you compose them, F of G, then if you start off at 1, you're going to end up back at 1. If you start off at 2, you're going to end up at 2 at 1, 2-to-1. If you start off at 3, you're going to end up going to 1 and then back to 3, so 3 goes to 3. And that's what we're saying right here. Right, F, 1 goes to 1, 2 goes to 1, 3 goes to 3. Now, in theory, they can do either in the order F and G or in the order G and F. They're different. They're not the same. F of G means that F, I kind of think of them as like little Pac-Man. Right, so like f of g means that it's, I like to rewrite it right away like this. I'll show you guys. F of g, I like to think of it as f of, because remember parentheses is kind of like of, f of, and then I'm going to do a different color here. G of x. So f, its input is the output of g of x. Remember, g of x is the y. X is the x. So this g of x, that's the y. I put in an x into g of x. I get a y. I take that y. That's the input. That's this thing inside the parentheses of my f. So I like to think of it as, let me stop sharing for a second here. I like to think of it as, where am I? Of kind of like a Pac-Man. Here's my X, right? My G eats it, and then the G sort of poops something out, and then F comes along and eats that, whatever the output of that G, and then its output is what you end up getting, right? So you have an X. If you're doing F of G of X, G eats it, and then F eats the G and kicks something out, and that's your actual output. It's so much easier in person. Oh, sorry, I'm gonna stop complaining eventually. All right, so that is your, this is F, G goes first. So think like this one, the one that's closest goes first. And again, like I said, I like to rewrite this right away. F of G, I like to rewrite that as F of G of X. And then this other one, if you had G of F of X, then that would be G of F of X. So that's kind of the order it goes in. You do F first. That output is what you throw into G. So make sure you guys pay attention to that because that's important. All right, so we're going to do some exercises. Using the functions of F and G on page 2 on the previous page, find the composition of F, G, and F. So sketch the mapping diagram and write the set of order pairs which represent the composite function. So first, we're going to do G of F of X. So we're going to do F first, then G, instead of the other way around. So this last page, we did G. So here's G. Right, I'll type them in here, maybe so we have them. So G is, again, G is 1 goes to 2, right? 2 goes to 2, and 3 goes to 1. F is 1 goes to 3, 2 goes to 1, and 3 goes to 2. So those are my two functions. I'm just going to write them there so I have them when I scroll down. Okay, so those are my functions, and I want to do, I'll move them, I guess I'll move them right there. Okay, so I want G, I want G of F of X. This is what I want right here. And I want this guy. So I need to do F first. So first we're going to do F. So you should all be writing this with me. And I like red. We'll do red first. Red. So I have 1, 2, and 3. And my outputs again are also the same thing, right? 1, 2, and 3. And again, you can think of them as like San Francisco, Paris, and London. And where do we go? Let's see. Where does 1 go in F? 1 goes to 3. 2 goes where?
To 1.
2 goes to 1. So you guys are drawing this on your sheet, right?
Yeah.
Yeah.
3 goes to 2.
Mm-hmm.
Okay, that's F. And then we have G to deal with. So G, let's see, we've got G over here. And you're supposed to kind of rewrite these. I like to just use this as the last part of my G personally. So G would take me from There was my spots, 1, 2, and 3.
1 to 2. 1 to 2.
1 to 2?
Yeah.
Sounds good.
Two
Let
to
me
two.
write these in first. So G says 1 goes to 2. Great.
And then
1
2 to
goes
2.
to 2. 2 to 2. Great.
3 to
Do
1.
you guys see where she's seeing these from? They're right here. 1 goes to 2. 2 goes to 2. 3 goes to 1. It's right in here. 3 goes to 1. So our composition, this is the part where, this is the kind of the money shot, right? It's right here. Composition is G of little circle F, which can also be written as G of F. All right, so here's my 1, my 2, and my 3, and my 1, 2, and 3. And in the long run, 1 ends up where? If I start off at 1, where am I going to end up with? Well, F is going to take me to 3, and then G is going to take me from 3 back to 1. So 1 goes to 1. Does everyone kind of follow that? It's saying, what's the bottom line? I started off here at San Francisco, I went to London, and from London, I went back to San Francisco. So started in San Francisco, I ended in San Francisco. 2, I started in Paris, I went to San Francisco, and then San Francisco took me back to Paris. Oh, well, heck, 2 went to 2. Also kind of boring. 3 went from London to Paris, right? And then Paris circled around and stayed in Paris. So 3 ended up starting off in London and ended up in Paris. 3 went to 2. Is that everybody following?
Yes.
Good.
Yep.
Great. Nice job. Thank you for the feedback. Okay. And then we're going to use function tables. So I'm going to erase this first part here and move on down. Clear drawings. So I'm going to clear this in 5 seconds. Take a picture if you need it. 5, 4, 3, 2, 1. You should all have it anyways. All right, so now we're going to use function tables to sketch mapping diagrams for functions f and g. Find the composite function f of g. So f of g, everybody text me, what do I do first, f or g when I do f of g? Do I do g first or f first? Half are correct, half are not correct. More are incorrect than are correct. Okay, so rewrite it. Again, rewrite it as what it should be. So f of g, I'm going to rewrite this as, do I need to make this larger? Should I make this bigger? Will that help people? Is that more helpful?
Yes.
Okay, great.
Yes, it is.
Okay, good. So I'm going to do f of g. I can even make it all the way. There we go. Okay, so I'm going to find f of g, and that's written as, so this, I'm going to read it as f of g, which is written as f of is parentheses, g of x. So let me grab this and see if I can make it larger. Select. Nope, it doesn't make it larger. Darn it, how do I make this bigger? Okay, no worries. So sorry, this is not that big. I would like it to be larger. Maybe I have to write it this way. F of, and then I see about this, so I can change the color too. F of what? F of g of x. So looking at this, what one do I do first? First, what happens to x first? G, right? G happens to X first. I throw in X into G, and then that output I throw into Y. So F of G, you do G first. So first we're going to do G. So here's my G of X. And I'm going to start off with 1, 2, 3, and 4. I'm going to end up at 1, 2, 3, 4. And I got to figure out where I'm going. So G of X grabs and puts me where? Let's see. 1 goes where? 1 goes to 2.
To 2.
Yep. Where does 2 go?
To 1.
2 goes to 1. 3 goes where?
To 4.
Yep.
4 to 3.
And 4 goes to 3. Good. Nice. Now we're going to do F. Then we do F on the rest of it. So here's my 1, my 2, 3, and 4. And my input for F is really G of X, because this is my, so this is my X. Let's kind of get things straight. This is my X. This over here is actually my G of X. These are my Y's. Right, my Y is my G of X. So maybe I'll erase this part here. Right, so this is my X I start off with. This is my G of X, kind of the Y that I get from my G. And then that's my input for my F. So at the end, I'm going to end up with this over here, which is F of G of X. Perfect. All right, so F is going to take what? F takes 1 and puts it where?
3.
3, great. So 1 to 3. It takes 2 and puts it to 4. It takes 3 and puts it to
2. 4 to 1.
And 4 to 1. Great. Terrific. So now we're going to do our composite function. I'm going to type it in because I want to. So F of G of X. Right, so I'm going to have all of my 1, 2, 3, 4, and my 1, 2, 3, 4 is what your sheet should look like. And then you're going to draw. So in the long run, if you start off at 1, you end up where? I go to 2 and then go to 4. So 1 ends up at 4. So understand? Right, 1 goes to 2, and then from there it goes to 4. So think like this. I'm in San Francisco, I go to Paris, and then I end up down here at 4. So this is San Francisco.
So 1 to 4.
Paris, London, and Brazil. Let's go to like Rio. Somewhere kind of fun and whatever. Okay, so San Francisco, you go to Paris. What'd you say?
It said maybe Europe.
Okay, all right, we won't go Paris. What do you want to call it? Where do you want to go? Greece? Do you want to go to? Okay.
Greece is pretty nice.
All right, we'll go to Greece. Perfect. All right, so San Francisco, you went to Paris, and then from Paris, you flew to Greece. So you start off in San Francisco, you ended up in Greece. 1 goes to 4. Make sense?
Yeah.
If you start off in Paris, you went to San Francisco, and then you flew back into London. So if you start from Paris, you ended up in London. So 2 ended up going to 3.
Yeah.
If you started off in London, you went to Greece, and from there you went to San Francisco. So you start off in London, you ended up in San Francisco at the end. So London goes to San Francisco, 3 goes to 1.
4, 1.
And if you start off in Greece, you went to London, and from there you went to Paris. So if you start off in Greece, you ended up in Paris.
3 to 2.
4 goes to
4 to 2.
4 goes to 2. Yep. Good. Everybody feeling okay about this?
Yeah.
Questions about
Yes.
it?
No.
Because now's the time to ask questions. While you're learning, you should be asking questions, right? This is totally, we don't expect you to know it all. All right, I'm going to clear this in 5 seconds. 5, 4, 3, 2, 1. And take a look. All right, so if the graphs are known, blah, 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 you can use it. I don't think this is important. It's just more words. All it's saying is f of g, this represents f of g of x. I still think that you should rewrite it. The first thing you should do when you see this f of g of x, do this. When you see this, rewrite it as f of g of x. Oops, why is it not writing? G of x. Someone has a very cute small child, sounds like. Okay, so f of g of x. So whenever you get this, rewrite it as that. Your life will be 100 times easier. And we would like to make life easier, not harder. Right? Math is supposed to make your life easier. Okay. Now we're going to look at it graphically. So here we find the composite function value f of g of 2. So first rewrite it as, very first thing I want you to do is rewrite this as f of what? F of g of 2. Okay, good. Now, can you find, so what do you do first, the f or the g?
Do the G.
The g. See, g of 2. You need to find g of 2. So, in other words, if I put in 2 for g, what do I get? Here's my g. If I put in, if my x is 2, here's my x is 2, right? So I want to find g of 2. So is 2 my x or my y, guys?
Your x.
X.
Yes, this is my x. 2 is my x. So then what's my y? My y is g of 2, right? That's what I'm trying to find. So what's the y? So when my x is 2, here's my x axis here, right? X is 2. My y, here's my point right there. My y is 1. So my g of 2 is 1. Is everybody following that okay?
Mm-hmm.
We did this before earlier with the function homework and stuff like that. You're just finding the x for the y. Now we're just doing it again, but we're going to do it in 2 parts. So this is the first part. So my g of x, g of 2 is 1. That's what I'm going to throw into my f. So now I'm going to do f of, I'm going to grab this guy. I'm going to put him into the f, right? Because that's my x for my f. So what is it? It's 1. I'm going to put in 1 here. Does that make sense? The output of my g is my input for my f. So I'm going to find, okay, well, when I have 1 here, let's see, here's my 1. Where does that go? It goes bump, 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 right there, this spot. spot. Here's my 1. This is where 1 would be, right? So this point here, my y is what? Y is 4. Do you guys see that? At this spot, my x is 1, my y is 4. This is 1, comma 4. So f of 1 equals 4. Right, this is on the homework you're turning in today, actually, stuff like this, I think. So f of g of x, f of g of 2 is 4. You can see down here. So these are kind of the steps that we did. We used the graph of g to find g of 2, which is 1. And then we used that 1, we threw that in to here, right, into f to find f of 1, and we end up getting f of 1 is 4. So f of g of x, f of g of f of, I'll do a different color so we're clear, g of 2 equals 4. I should erase off those little bits because I tend to get messy with my, oops, uh-oh, it's going to erase all of it, isn't it? Okay. All right, so that's the end result we get. Questions? You guys have been doing this in your groups pretty soon, so make sure you all have a handle on it. And like I said, you're learning this. I do not expect any of you guys to know this. So if you have any questions, totally okay to ask questions. All right, I'm going to erase this in 5 seconds. 5, 4, 3, 2, 1. Good. This is just showing it again, right? This is kind of them showing you the graph that I just showed you a second ago. You find your x, your input, you find the y, you take that, you take that number, you find the y, and you throw that in as the x for the next one, and you find the y of that one. So this is what you guys are going to be doing. You're going to be taking the input, the x, going up, finding the y, taking that y, 1 in this case, using that as the x for the next one, and then finding the y for that one. And sometimes it'll go left to right. Occasionally you have to go right to left. It gets a little bit, I'm going to ask you, these are f of g of x, right? So g is first. So this is, it's going left, left to right. But then these ones here are going to go g of f of x. So you're going to do f first. And again, like I would say, please, I would rewrite these right away as g of f of x, f of 2. Which I might write it higher. So I might write it, let's put this over here, right? And then find what f of 2 is. So here, find what f of 2 is. Here's, oh, sorry. This is totally wrong. That's wrong. Let me delete that. Trash
Isn't it f outside
it
g?
Is. It's totally wrong.
F,
Yeah, I'm so sorry. It is it's f of equals f of, yeah, f of g of 2. I'm so sorry.
That's okay.
So you're going to find g first. So find g of 2. Let's see, when I have input of 2, this I'm going to have output of -1. Someone see that? Everyone agree with me? G of 2.
Sorry, g of 2 is x, or g of 2?
Yeah. No, 2 is my x.
2 is your x, but
yeah,
g of 2
is -1.
Negative. Okay, thank you.
Yeah, because see, if I input 2, I'm going to end up with an output of -1.
Yeah, thank you.
So that's the same as saying f of, well, now I know that g of 2 is -1. So I can just put in -1 in there instead of G of 2, and then find f of -1. So when f is -1, let's see, when my input's -1, that's right through here. I get to this spot right here. So the output would be this guy right there. Looks like -3. Okay, I'm going to send you guys off to your rooms to work on this. Move this thing out of the way. Okay, so I'm going to go and open up the rooms. Oh, let me text you guys the Jamboard. So the Jamboards, oops, these should be the Jamboards. Why are these guys not in here? Oh, we already did those, did we? Oh, hang on. I already did this one.
What page is that? Yeah, you did this one, but.
Yeah, so Jamboards, we already did #1 and #2. So you're on page 3 of the Jamboards. Page 3 and 4 are the two you're doing. We did almost everything in class. So I'm going to go ahead and text you guys the address of the Jamboards in case you need them. Copy them. I'll chat it to everybody. So there's the Jamboard link to this page, so you can find your Jamboard. I'm going to open up the rooms now. So if you're in breakout room 1, obviously you go to 1, breakout room 2, go to 2, and so forth. And just do pages 3 and 4. We already did pages 1 and 2 on the Jamboards.